everyone, this is Sukesh Kulkarni and you're watching Cosmic Science. Suppose I have a spherical ball and I want to make it stand still. How do I make it stand still? Suppose this is the surface and this is my sphere. I want to keep my sphere intact. I shouldn't make it roll. How do I make it? If I apply a force to stop it from here, it will move ahead in this manner. But if I apply force from here, the this sphere will move in this direction. So how do I make my sphere stand on particular surface as a still? How do I make it? So how do I make my sphere stand on one place without any movement or rolling movement? Let's see that. This is my sphere. Okay. If I apply force in this direction, it will move this side. If I apply force from this side, it will move this side. But here is the interesting thing. If I apply force from this side and even from this side, the sphere will not move because two forces are acting in the opposite direction with the same force. So this state is called equilibrium state. So two opposite force acting on the sphere and it makes it stand still in equilibrium. That is state is called equilibrium state. So in laws of motion, equilibrium is defined as it is a state where the net external force acting on the body is in opposite direction and they are equal in magnitude. So this is the state of equilibrium. So I am applying force here to make my sphere at equilibrium state. This force should be a resultant force. What is resultant force? It is a force which is produced and it is equal to a force, multiple forces. It means that if I apply a force on this on stone multiple times, if I apply force multiple times on this stone and it gets break, and in another scenario, if I apply a force in such a way that in one shot it will break the stone. So this force is called resultant force. So this force is called resultant force. So coming back to momentum, I just got missed about it. I would like to introduce a theorem, law of conservation of momentum. What it says that momentum of a body moving with a velocity v are conserved. Suppose two objects. If two objects are moving with a momentum 1 and momentum 2 in this direction, they have momentum P1 and P2 and they are moving in the opposite direction and they are going to collide. So what happens when they collide? When they collide, they won't exchange the velocity. How is that? P is equal to mv. This velocity will not be exchanged because after they collide with the same velocity, they are going to get apart from each other. So they won't exchange the velocity. So this is said to be law of conservation of momentum. So how do we prove it? Let's prove law of conservation of momentum. Let a body is moving with a momentum P1. Let the another body is moving with a momentum P2. So by Newton's second law, we have F is equal to dP by dt. So as momentum changes, the force is going to change, and if force is going to change, this momentum is going to change. So we can write force from momentum, which is given as this is first equation. Here force experienced by one is given by change in momentum divided by change in time. In second case, force experienced by second body is equal to change in momentum of the second body and divided by change in the time. So by Newton's first law, we have force 1, 2 is equal to force is equal to, so forces are equivalent and they are in opposite direction. So force in this direction and this force is in this direction. That is why we take negative sign here. So substituting the values here, these two equations, we get it is a negative sign. So dt and dt get cancelled. What remains? So what remains here? P2 minus P1, negative sign, P2 dash minus P1 dash. So this is the equation we have. This shows that change in the momentum of one body and change in the momentum of another body are opposite in direction. So by this we will see how the momentum is conserved. So if I take these terms, if I interchange them, we get this equation shows that momentum is conserved when two bodies are moving in opposite direction and they collide with each other and they conserve the momentum. So this was about law of conservation of momentum. Also we have studied equilibrium. So in coming topics I will be covering some more concepts about laws of motion. So please, if you like it, please hit the like button, subscribe and share with maximum people so that they can get this knowledge in a simpler way. See you in the next video. Thank you.